variation, and we are going to look at joint variation. Now, first, what do we understand by the term joint variation? Joint variation comes from direct proportion and inverse proportion. For example, we know that the volume of a gas is inversely proportional to its pressure. That means when volume is increasing, pressure is decreasing. So that relationship whereby one factor leads to increase in one factor leads to increase in the other one, or vice versa. That is when volume is decreasing, pressure is increasing, that is inverse proportion. But also, volume is also directly proportional to temperature. So, if volume is inversely proportional to pressure, and the same volume is directly proportional to temperature, the second statement means that when the temperature increases, volume increases. So, the two statements, that is V is equal to K over P, and V is equal to KT. This means volume is directly proportional to temperature, and here volume is inversely proportional to what? Pressure. So when you combine these two statements, you come up with what you call now joint variation. Now let us try to come up with a question that you'll be able to understand the whole concept. So example 1. You're given that three quantities, P, Q, and R, are such that P is directly proportional to Q squared. Is directly proportional to Q squared, and inversely proportional to square root of R. So we have got three quantities, P, Q, and R, which are connected by this statement that such that P is directly proportional to Q squared and inversely proportional to square root of R. Now, A, we are told that when P is 10, Q is equal to 2, and R is equal to 36, then you're told determine 1. The relationship between P, Q, and R. Number 2, find the value of P when Q is 5 and R is equal to 81. So that is part A. Then part B of the question, you're told Q increases by 20% and R decreases by 36%. Determine the percentage change in P. Determine the percentage change in P. So in the first part of this question, you have 4 marks, and the second part you're having 6 marks, which gives you 10 marks. So how am I supposed to come up with the solution for this question? So let's go through the question once again. That 3 quantities P, Q, and R are such that P is directly proportional to Q squared and inversely proportional to square root of R. When P is 10, Q is 2, and R is equal to 36. Determine the relationship between P, Q, and R. Find the value of P when Q is 5, when R is 81. Part B. Q increases by 20% and R decreases by 36%. Determine the percentage change in P. Now, let's work out this question. Let's start with part A. Okay? Now, you're told you have got P, Q, and R. And they are in a relationship that P is directly proportional to Q squared and inversely proportional to square root of R. So this is the connection between P, Q, and R. But you're further given that when P is 10, Q is 2, and R is 36. So where I have P, I'm going to use 10. So 10 is equal to K into bracket 2 squared into square root of 36. So this gives me 10 is equal to 4K over 6. So multiply by 6 over 4, multiply by 6 over 4. This and that cancels, and this cancels. So therefore, I'm having my K as 10 times 6 over 4 by 2, 2, by 2, 5, by 2, 1, by 2, 3. So K is equal to 15. So the first question in part A is that determine the relationship between P, Q, and R. So that tells you that the relationship between P, Q, and R is that P is equal to K, Q squared over square root of R. So now the value that you have for K, you substitute in the equation, and you're going to have P is equal to 15 Q squared over square root of R. Now that is how you get the relationship between P, Q, and R. Number 2, you are asked that find the value of P when Q is 5 and R is 81. Now from part 1 you have P is equal to K. In this case your K is 15 Q squared over square root of R. So you substitute that 15 into bracket 5 squared divided by 81, square root of 81. So you're going to have P is equal to 15 times 25 divided by 9. So you have your answer as 15 times 25 divided by 9, which gives you 41.7. So that is how you do part 1. Now part 2, so part A is where you're looking for the relationship between the factors, the relation between the points that you're given, and number 2, the value of one of the factors that you're given. So let us look at part B. Now in part B, we are supposed to determine the percentage change in P. Percentage change in P. So how do we do that? Now from this question, you are told that Q increases by 20% and R decreases by 36%. Now to get the percentage change in P, you apply the same rule where you say P is equal to K Q squared over square root of R. Therefore, that means if Q changes, it will have an impact on P. So if this one changes, this must change. If R changes, then P must change. So therefore, we come up with one more step and say P prime is equal to K Q prime squared over square root of R prime. The prime means the percentage changes, because if Q changes, then P must change. So in this case, you have your Q prime as 120% of original Q, which is going to give you 1.2 Q. Your R has decreased by that 6%. It means you have 64 over 100 times original R. That means our R prime is equal to 0.64 R. Now, since we have said P prime is equal to K into Q prime squared divided by square root of R prime, then it means P prime is equal to K into 1.2 Q squared over 0.64 R squared. So that means my P prime is equal to K times 1.44 Q squared, because 1.2 squared you get 1.44, divided by 0.8 square root of R, since 0.64 square root is equal to 0.8. From this, you're going to have, if you put the like terms together, P prime is equal to 1.44 K Q squared over 0.8 square root of R. That tells me that P prime is equal to, you take 1.44 divided by 0.8, which gives you 1.8 KQ squared over square root of R. From this explanation, this part, that is KQ squared over square root of R, is equivalent to the original P, which was 100%. Therefore, our P prime is equal to 1.8 times 100%, which is going to give us 180%. So that tells you that P increases by 80%. So that is how you do that. So let's look at another question under joint variation. We have another example we can have. Let's pick one question from KCSE past papers. For example, in the year 2004, this was a question that three quantities P, Q, and R are such that P varies directly as the square of Q, P varies directly as the square of Q, and inversely as the square root of R, and inversely as the square root of R. Then you are told this way. This is the question, part A, that given that P is equal to 20, when Q is equal to 5, and R is equal to 9. Find P when Q is equal to 7 and R is equal to 25. Part B of the question, you are told that when Q increases by 20%, when Q increases by 20%, R decreases by 36%. When you are asked, find the percentage change in P. Now, this is exactly the same question that we were doing. So let's try to see how are we supposed to work out this question starting from part A. So you've seen that we are told that P, Q, and R are such that P varies directly as the square of Q and inversely as the square root of R. When P is 20, Q is 5, and R is 9. So let us work out that question, part A and part B. I'm told P is equals to 20, when Q is equal to 5, and R is equals to 25. Now, I'm supposed to get P when Q is equal to 7, when P is 20, Q is 5, and R is 9. I'm supposed to look for P when Q is 7, and R is equals to 25. So let's work out that part A. Now, in this part, you're looking at if P is equal to KQ squared over square root of R. So part A, I'm supposed to substitute these values I have. So I'm going to have 20 is equal to K into bracket 5 squared over square root of 9. This gives us 20 is equals to 25K over 3. So multiply by 3 over 25, multiply by 3 over 25, so that you have your K as 20 times 3 over 25. Now, that will give you K as 20 times 3, that is 60, divided by 25, you get 2.4. Now, if K is equal to 24, then the equation connecting P, Q, and R is that P is equal to 2.4 Q squared over square root of R. Now, since they are giving us value of Q and R, and you're supposed to look for P, then P is equals to 2.4 times 7 squared divided by square root of 25. This will give us P is equal to 2.4 times 49 divided by 5. So our P is equal to what? Is equals to 23.52. So that is how you work out part 1. Now, let's now look at part 2, where you're looking for percentage change in P. Now, from the question, you're told that Q increases by 20% and R decreases by 36%. So what do we do? You're having P is what you're looking for. Our Q is equal to, increases by 20% and R decreases by 36%. So original question, original term, P is equals to K Q squared over square root of R. This one is equal to what? 100%. Now, we say that when Q changes, P must change. When R changes, P must change. So therefore, P prime is equal to K Q prime squared over square root of R prime. That tells us that for us to get P prime, we must substitute Q prime and R prime in the equation. So therefore, our Q prime is equals to 120 over 100 times original Q. So Q prime is equal to 1.2 Q. Again, our R prime is equal to 64 over 100 times original R, which gives us 0.64 R. Therefore, P prime is equal to K into bracket 1.2 Q squared 1 square root of 0.64 R. This will give us P prime is equal to 1.44 K Q squared over 0.8 square root of R. So our P prime is equals to, you take 1.44 divided by 0.8, you'll get 1.8 K Q squared over square root of R. we agree that kq squared over square root of r is 100%. So our p prime is equal to 1.8 times 100%, which is going to give you 180%. So from this explanation, we can say p increases by 80%. So that's how you get the joint variation.